और भाई कैसे हो? So let's see today's cheat code problem of the day. Today we have a difficult question. See, it's difficult. So let's first try to understand the problem. So for how to tackle difficult question, basically think for 10 to 15 minutes. Let's make it a like hard and fast sum no. Okay, if you don't do this, sometimes you just go and you code something, and later you come again, and then you again have to change your approach, and that will not work. So just first try to establish a fixed approach that you are going to take for the hard questions. Then only always try working on them. So let's see what do we have, right? Our task is to find number of pairs of subsequences. Oh my god, pair of subsequences we have found. Both should be disjoint. Okay, and their GCD should be equal. Okay, what does it mean? So let's say x1, x2, x3, x4. This is a right. This is an array. Then what can be its subsequences, right? X1 can be a subsequence, right? Other sequence can be x3, x4, right? I can say x1, x2. I can say x3, x4, and so on. Basically, I can say x1, x3. I can say x2, x4, right? X1, x2, x3. Then I said x3, x4, right? This is not valid. Why this is not valid? You see, x3 is counted in both of them, so it right does not include this condition. All these are valid, right? So it's kind of right. Pick non-pick, right? 0 1 problem. Just I'm telling you for reference. It feels like 0 1 knapsack. Let's see what we are going to do now. We need this. Then just GCD equal, right? So I'm going to say right GCD of x1 comma x3. This should be equals to what? GCD of what? Take this one, huh? GCD of x2, x4. If it's equal, it's a valid pair. Valid pair constraints are right and less than equals to 200. Okay, and right this nums of I less than equals to 200. Okay, what does it means, right? If nums of I less than equals to 200, right? Then see GCD of a comma b will always be less than equals to, right, maximum of a comma b, right? So right, our max, right, our max GCD equals to what? 200. Okay, total number of elements is also 200. Now how to tell it? This is difficult. So it's kind of 0 1 abstract, but what? Let's say I am at any index I, right? At any index ending at I. Okay, so there's a I minus 1 state, right? At I minus 1 state, I can have GCD values, right, ranging from 0 1 till 200, right? This is range. I don't know which one is true, right? But we can have these many states, right? Because the max GCD is 200. So then at this current state, right, I have my nums of I, right? Now I have two sequences, remember this one. So one sequence is right G1, one sequence is G2. So G1 has some elements, let's say 0, first and some second element. G2 has some third element, some fourth element, and now we are at I equals to 5, right? Then this nums of I, right, either add to G1, right, or to G2 over skip, right? Can I do all three operations here? Okay, so now what do I write? I can say, right, dp of, right, dp of what do I need? I need all these G1 values, right? So first will be 200, right? This is my G1. Another state will be 200. This is my G2. And I also need the index. So I'm going to say it, right, dp of index. Now, what does this represent actually? So any value, right? dp of index I comma j. What does it represents? So what does it mean? It means, right, at any index I, right? At any index I, right? Count of two, right? Valid subsequences. right? With GCD equals to what? See, I and J. With GCD I and GCD equals to J, right? So then what will be my answer, right? So at last index, right? At last index, right? When both these GCD values are equals I equals to J, this is I need, right? Okay. So so what we are going to do, right? We initialize it DP initially 201, 201. Okay. Then what I'm going to do, right? The base condition is what? My DP of 0, 0, 0 equals to 1, right? This is true. Okay. Then what, right? Then I loop over, right? Each index for I equals to 0 to n. Now at each index, what do I have to do? Right? This each index can be part of either G1 or G2. So I have to loop over all possible values of G1 and D2. Let's say for G1, right? It's to 0 till n. So let's say it max, right? Max equals to 201. Or you can say max equals to maximum, right? Element of array. Okay. Now the same I have to again loop, right? For G2 equals to 0 till max, right? So now tell me, right? Uh, okay. Now what do I have to do? Right? I can, okay. So now what was my previous, right? DP of, right? Previous index, I minus 1th index, G1, G2. This is my previous count, right? Okay. Now what can I do on this step, right? First is skip. If I skip, then what happens, right? Right, then DP of I, G1, G2, what it becomes, right? Plus equals to count, right? If I add to G1, what then happens, right? Then I will take, right? G1 new equals to what? Right? The GCD of what we already at G1 and what is my current element, right? Nums of I, then what I'm going to do, right? DP of current index, what is my new value, right? And G2, right? This plus equals to what I have there, right? Plus count. Okay. So what is the next value, right? If I add it to G2, right? When I skip, I add to G1, I skip add to G2. So what will become, right? G2 new, right? GCD of, right? G2 comma nums of I. So I can say, right? DP of I, G1, right? G2 new plus equals to count, right? So I prepared all my GCDs now, right? Now what will be the answer, right? Just hit straight to a right for G equals to 1 to max, right? Why 1? Because if it's GCD equals to 0, that means, right, no element, right? Even if there is a single element, then GCD will be equal to that element. Okay, then what we are going to do, right? Answer plus equals to what, right? DP of last index, DP of n, right? N minus 1 and what? Where both are equal, right? G equals to G. So this is your answer. Okay, now I hope you understood the question, right? What is the time complexity? Time complexity is what, right? Of n. N is the length of array, right? Then what? M cross M. What are M, right? Right? And max value of nums of I. Max value of nums of I. Right? Or you can simply write 200 because we know, right? We know the constraint in the question is, right, this one. Okay, so yeah, let's see the implementation part now. Thank you. Okay, so let's see the implementation part. What do we have to do? We need a DP, then compute answer for G, right? For G comma G, right? For last index, right? And what G comma G, right? Where both these are same. Okay, what see. Okay, right. So we have to do these two things. First is we need a DP, and second is we need to compute answer for the last index. So first let's initialize the DP, right? So I can initialize a 3D DP, right? DP equals to what? New long. So right, all of these, right? This side 200. Just say right the max value. And I can say right DP 0 0 0 equals to 1. This is base case, and I have to loop, right? For int I equals to 0, I less than ni plus plus, right? Then what I do, right? Right? G1 sequence, right? For int G1 equals to, right? 0 G1 less than equals to, right? 200 G1 plus plus. Then right? What will be next, right? G2 sequence. G2 sequence, right? Right. G2 will start from 0. 0 means, right? There is no element till now. G2 less than equals to 200 and G2 plus plus. Now, what I'm going to do here, right? Mm, so what we are going to do first is we can skip, right? We skip, right? Then what I'll say, right? DP of next, right? I plus 1, right? G1, G2, right? So let me take first current, right? Long current equals to what, right? DP of I, G1, G2, right? The value that I had, right, on the previous one, right? So right equals to what, right? This DP of I plus 1, G1, G2, right? Plus current percentage mode we have to take. So I'll define mode equals to, right? Okay, then what, right? Add to G1 sequence, right? Then what will be my new GCD, right? Int new G1 equals to what, right? GCD of what? G1 comma what is my current element, right? Nums of I, right? Then what I'm going to do, DP of I plus 1, right? New G1, G2 equals to what? DP of I plus 1, right? What I'm going to do there, right? New G1, G2 plus current percentage mod, right? And if we add it to G2, right, then what we are going to do, right? Continue G2 equals to, right, GCD of what? G2 comma nums of, and then I can say, right, DP of I plus 1, G1 new G2, right? This is equals to what? DP of I plus 1, right? And then G1 new Z2, right? And I'm going to add the current, then we are going to take the mod, right? Okay, so we have prepared our, we need to write the GCD function, right? So what else, right? int GCD, int A, int B. So what is the GCD of two numbers? So right, so that's standard, right? If b equals to 0, we return A, right? Otherwise, what we return, right? Return GCD of b comma A modulus b. This is a standard GCD function. Okay. Now we can actually pre-compute the GCDs. Let's see if this works. If we get TLE, we can pre-compute this one. Then what will say, right? I'll say long answer equals to 0, L4 and I equals to, right? equals to 1, right? Let's say it's g equals to 1, GCD, right? Then g less than equals to, right? The maximum can be 200, right? G plus plus, then what is my answer, right? Answer equals to answer plus what? DP of last index, right? Then what is the last index we define? No. And n equals to nums dot length. Okay, then what we are going to do here, right? Right, n g g, right? We'll take its modulus, and what do we have to return in that? We have to return the int. Okay, the same script. Let's see. Okay, this works. Let's submit this one. I hope it works, but let's see if we get TLE. I think we can get TLE. Okay, now we can actually let's pre-compute the GCDs because we know, right, it's between 1 and 200, so we can do like, right, I can do int, right? I can say g, right, GCD dp, right? Because it's new int, the same, right? 200, 201. And what I can do, right, for int I equals to, right, 1 I less than equals to 200 I plus plus, right? For int j equals to 0, j less than equals to 200 j plus plus, right? And I can say, right, GCD of dp of what? I comma j, right? What I can say it, right? It's GCD of what? I comma j, and at this place, right? We use GCD dp, right? We use I comma j. I can say, right, nums of I. Seems good to me. The same we have to do here, right? GCD of dp. Okay. Let's see if this test is passed. We're getting some compilation error. Okay. Okay, accepted. Let's submit now. Please work. Okay, we are still getting TLE. What else we can do? Time complexity seems fine. Right, right. And let's decompose this DP as well, right? We only need the current state and the previous, right? So I can say, right, let's make two DPs. So, right, let's make this DP. This is my current DP. This is okay. And what do I am going to do? I need a previous DP. So I need a basically long right? This will be my next DP. Right, this. Okay, this is my next DP. Then I can say, right, this thing. Right, this I can say. This I can say, right. Next dp this I can say. Next dp this I can say. Next dp I can say it will be like simply dp of this one, right? And what do we do here, right? At the end we copy this dp values, right? What do I do, right? For int I equals to 0 I less than ni plus plus, right? Not ni. But, like I don't know if we can copy, right? How to copy a array term? Second array in Java. Like C++ you can simply do, but I don't know how to do is here, right? Source destination or is dot copy and copy dp to next dp. Oh, next do destination of I, right? The source on destination. I don't know. Let's just copy it. Right, 201 I plus plus for j equals to 0 j less than 201 j plus. So what I'm going to do, right? The current dp, right? dp of I comma j equals to next and dp of I comma j. Just simple. That's fine, I think. Okay, this one, right? See what do we have now? Variable I is already defined now. xi. Sometimes when I don't have a laptop, it's really difficult to code. Mm, it's just we, right? That this is not an optimization. It's like the 3D dip is little bit, right, complex. So the operations are heavy. So we are just reducing them. Okay. Yeah. Good. Thank you. So it does not directly affect the time complexity, but the operations it take to get access and update to 3D DP are heavy. That's why. So let's see the time complexity now. Okay, analysis. And there is one, I think, Mobius inversion or some theorem. I know, but I just don't remember how to code in that one. But that we can sometimes use, right? But our time complexity is already excellent. We can further optimize it, but that's fine. Yeah, thank you.